My name is Larry Bordowitz, and I want to welcome you all to our Jenkins user conference talk at CD at Yahoo, and Yahoo Mail specifically. We know you had a choice of talks to attend, and we're so glad that you chose ours. And we're so glad that you found this room. Anyway, so we're Larry, there's James, Aravind, Gopi. We're software automation engineers at Yahoo. When we started out continuous delivery deployment, CD was already a part of Yahoo. We brought our own unique spin to it, so we implemented a CD pipeline for Yahoo Mail specifically. The challenges that we faced and the patterns that we implemented, they're generic enough they can be used anywhere, and we're glad that we can share them with you today. So I want to talk a little bit more about those challenges. But first, there's a little social media hashtag if you want to say hashtag Jenkins conference, hashtag Yahoo Mail CD. Wouldn't mind that at all. So right, those challenges. So starting off with the challenges that we had, here's set up the scene a little bit. In the beginning, in an office building 3 miles away, we had hundreds of developers, and they're all working on a shared code base. They're all changing like thousands of lines of code daily, and the whole code base is millions of lines of C++ and Java code. In Yahoo Mail, we have tons of components. They all interact with each other, but very few of these processes were fully automated. So there's lots of human intervention present, and with humans being the #1 source of error in any project, rolling out changes was prone to error. We had to worry about whether test suites were run properly or at all, whether the product was packaged correctly, and worst of all, we had to pray that deployments went well. Because if deployments didn't go well, that meant more manual intervention to fix what was broken, and then we needed to roll back, and then we needed to repeat the entire process over again. And that's a lot to expect from our developers. And our developers are good, really good, but they ain't perfect. So prior to having CD, when bad changes were introduced into the code base, it was a real headache. Sometimes they would be really simple mistakes that could be avoided, but for one step gone awry in a 20-step production push process written in some wiki somewhere. These were the kinds of accidents that we were looking to reduce. These are the change-related issues. So if hardware goes bad, fine, that's life. There's redundancy for that, but it's different if our users can't get their mail because a developer forgot one step in that 20-step production push process. That's on us. That's avoidable. So we are looking to we're looking to reduce change-related issues as much as possible through robust, automated processes that do the heavy lifting for us. So we wanted to do that. We also wanted to increase developer productivity. So what we wanted to do, we wanted to increase the amount of time that our developers spent writing code. That's what they're for. That's what they do best. We want to automate the things that they hate doing, so running tests, validating changes, pushing packages to servers, and leave them with the only process that we couldn't automate, writing code. So in doing so, we'll make a process of releasing this code. We want to make that as reliable as possible. So reliable, we want predictable, and as long as nobody messes with the systems that are set up to automate these mundane tasks, once they work once, they'll work forever. That's the theory anyways. So those were our goals, to decrease change-related issues and increase developer productivity. And to achieve these goals, our CD pipeline went through, you can think of it as 3 phases. Today we're on the 3rd phase, but to understand how we got there, we'll have to start at the beginning. So to present phase 1 of the Yahoo Mail CD pipeline, I'll let James take over. James?
Thanks, Larry. So, phase 1, we spent a little bit of time researching what we were going to use to do CD, and after much deliberation, we settled on Jenkins over Hudson. We had both available at Yahoo, and the joke was that even the Hudson guys were using Jenkins, so we figured, why not? What's the worst that could happen? Let's use it. So we took a little bit of time, we set up our infrastructure, we set up bunches of slaves, we set up a master with failover, some simple data backup, and then once we had the infrastructure and software running, we set out to take all these wikis and runbooks and turn them into code. Now, In the process of doing this, you get a free, kind of like a bug squashing event. All these runbooks that have problems, you have to turn them into code, so you discover all the problems in them that developers would have hit. Bunch of issues avoided right off the bat. And now they're in code. So I'll go over the basic pipeline that we pretty much designed for all the products. All these different components in Mail, they're all unique, they all serve a different purpose, but they're all built, tested, and released in very similar manners. If you have a product that has a unique build and release process, you have a product with its own unique problems. So patterns are a good thing to do. This was our first phase, so it's a very simple pipeline. If you have any CD at all, it should seem very familiar. In the commit stage, we take any change push to the source code, and we just kind of compile it. We run static code analysis, run linters, unit tests, just real basic rough things to make sure they didn't break the code. After that, if it passes the commit stage, we move to the assembly stage. The assembly stage is pretty much like the commit build with one difference. The code isn't just thrown away after it's built, it's actually packaged and pushed to a package server, which then begins the next phase, the actual assembly phase. We take all the different states of all the servers running this component and regenerate them with the new packages and any other changes needed to run the new package. Once we do that, we tag the new states with an identifier that ties it to the source code used to produce that new package. Traceability, it's very important in a CD world when all these things are happening automatically. You need to see what's happening where, and this helps identify changes. So once they're tagged, we move off to the deployment phase. We take the states for the QA servers and we push them to the QA servers. They take the new update and then we run a series of tests on them. Integration tests, functional tests, a light suite of performance tests, things that would generally happen if all looks good. The state is promoted to all of production, all our users get the new version of Mail, whatever it may be. So once we automated most of these processes, we kind of gauge what the developers thought of it, and turns out the developers loved it. They just had to write code. Anything they committed just got built and tested. So it enhanced their lives greatly. In the spirit of Jenkins, we started exploring different plugins to add functionality to these builds. Now, none of these plugins are unique or have any sort of special feature, but the ability to deliver a consistent level of functionality across projects without custom scripts is an unparalleled feature. No more custom scripts, check out Git repos. You just click a drop down and it's there in your project. I'd like to highlight some of the plugins that we initially implemented that are still around today, in our server. We installed the Jacoco plugin. We had a lot of Java projects using Clover, and to be very honest, Clover wasn't that great. We found Jacoco, builds got faster, builds got more reliable, all the Java devs, happy as a clam. The Git plugin, around the same time we set up Jenkins, people started moving to Git. So we wanted to support their move to Git. We installed the plugin and allowed them to check out their new source code. If they were in the middle of a migration, we installed the multiple SCM plugin. They could then check out both what they had in the previous SCM and now Git and run both. The build blocker plugin is super handy. It allows lightweight resource constraint all through Jenkins. If your pipeline has integration tests and someone commits a change, you don't have to worry about the deployment phase going and wiping out your running test. It will wait. And prior to that plugin, that happened a lot. You'd be surprised. Lastly, the build highlights plugin is very invaluable. One problem even today is that debugging a build log is hard, especially a Java Maven build. There's megabytes of lines, and it really does suck to have to dig through those to find, oh, Maven didn't fetch a dependency. Bummer, I gotta rerun it. This little plugin highlights patterns and displays them on the build page so that developers at a glance don't have to dig. They just look and know, okay, it's my problem, or oh, okay, rerun. So the Jenkins plugins really did enhance our lives. It made things real easy for us. We could focus on custom things that weren't in that form. So things look good, right? Yeah, all the problems that we had with people not following the processes right, those were gone. Now move to the front of the line, all the infrequent issues, all the hiccups, and all the different things we didn't handle with pipelines. So teams were still looking to bake changes. What that is essentially a phase between QA and production. The tests they were running in QA they were good, but it didn't cover everything, so a lot of teams felt more comfortable if they could, roll it out to a small set of servers, let it sit for a week, maybe two, maybe a couple days, and then they could gauge if things were good that way. The problem with that is it requires manual intervention, something we sought out to reduce. So those performance tests I talked about, they're good, but we still had issues that were being uncovered during peak hours. No matter what we did, we would still find bugs that, no matter how comprehensive the test suites were, they just didn't catch them. So people went back to the baking to try and catch that. Lastly, we had people who weren't in the mindset of CD. When things broke in the pipeline, they didn't come to us to get help. They didn't try to fix themselves. They just worked around the problem. Oh, it didn't push the QA servers. They log into the QA servers and tinker, find out what's wrong, and go on with their lives. The problem with that is they wouldn't reset their tinkering. And the pipeline, maybe it made a bad assumption that things were in a certain state, causing false negatives, or even worse, false positives, blocking the pipeline and just getting our devs stuck for hours. People would claim Jenkins is broken. That's wrong. The process was broken. Jenkins worked fine. It did everything it was supposed to. So, even with all this automation, we still had issues. We rolled back frequently. Now, thankfully, we had jobs to do rollbacks, so people didn't have to push by hand, but it was still happening. The whole point of this pipeline was quality, and we still had bad changes making their way through it undetected. In the case of something that required a patch, maybe it was a security hole, they couldn't use the pipeline, or rather, they didn't want to. Timing was of the essence for these things, and they didn't want to sit and wait hours for their tests to run if it's a simple line change. So people would push those packages by hand to fix things. Again, manual intervention, bad. Jenkins should handle all of this. They just write code. Worse, if it wasn't even a security patch and someone was just impatient, they just pushed the package by hand. It wouldn't matter. And yeah, sure enough, the pipeline would be right. It would cause a problem. We'd have to roll back. And yeah. So despite our best efforts, we still had people involved in the overall build release process. Not just us, developers, the people we tried to cut out. So as far as we were concerned, as far as our bosses were concerned, this whole CD thing was a sham. Man, we sought out to prove that wrong. So we took a step back. We looked at what went right, what didn't go right, what we needed to enhance. We met with our developers, and we moved into phase 2, which Aravind here will talk about.
Thank you, James. So just like our CD, I think we have a speaker pipeline. So as James mentioned, step 1 was the right direction for us. So we did many things right. A lot of things were automated. The release was a robust process. There was testing, but not being enough. So we went back to the drawing board. We figured out, we spoke to developers, and then we looked at the last few releases, what went right. Then we listed down what were the problems. Problem number 1, the QA environment was shared. Also, given the complexity of mail, sometimes not all features tend to release at the same time, so they had varying release cycles. And also there were several downstreams. For example, front-end tends to release more frequently, web service little bit less, maybe twice a week or so. So that was problem number 1. Problem number 2. So this was the one we wanted to attack more, because baking changes was bad in the sense, though we had alerts set up, it was not uniform across the teams. Some people preferred baking for 2 days. Some people said I want a week. But then what we found out was just baking for a more time gives you that false confidence that things are right. Nobody alerted us or nobody complained. The release is good. But then once you go to production and expose it to more users, you never know. So we wanted to get rid of time-driven promotion. Then reverse engineering. So one of our goals, if you remember, is improving our developer productivity. So because of this pipeline, things were found in production, people debugged in QA, a lot of time was getting wasted for developers. So tracing the change was painful. So how did we go about solving them? So this was how our old pipeline looked. So we had, from QA, we were pretty much releasing it to our internal servers, very few users doing baking, then pushing forward. So we came up with this concept of staged deployments in multiple phases. What do I mean by that? So in the new pipeline, we introduced 3. First one is alpha. So alpha is all scenario testing covering all environments. For example, as I mentioned, one of the problems was some features are on or off. So what alpha does is it tries and runs for all possible combinations and sees whether it worked with the feature off, feature on or off. So that was covered by alpha. Next is beta. Beta is what we call our low risk state certification. This is the first exposure of the product to few outside users or like first level of traffic. So this one usually covered stuff that wasn't covered by alpha and also gave us some real world scenarios which we didn't cater to. Next one was gamma. So gamma is where we wanted to catch issues with respect to load and also stress testing. Agreed, we had some stress testing as part of testing, but we wanted to do it with real users. So what we did was, we did an intelligent way to pump as much traffic our servers can hold in production with real users, and then figured out whether the build is good or not. But how did we do this? So we came up with this thing called metrics-based promotion. Instead of time-based promotion, we wanted to make that process as automated as we can. So we started measuring things. There are two types of metrics we did. Like one is system metrics, which is covers CPU, memory footprints, and then latencies and stuff. In addition to that, we had application metrics. For example, like we had 10 APIs. For each API, we had error rates. Like this, for 1 million requests, what's the percentage of errors we can live up to? And for latency, like what's the round trip time? So for an API call, what's the latency you can live, like 100 milliseconds or not? So we had these metrics written, and whenever the build goes to beta, it collects the metrics. Once the build is good on beta, the build gets promoted to gamma. So this was how our pipeline looked after phase 1, commit, assembly, and deployment. We spent a lot of effort revamping this phase. So as of phase 2, how did our pipeline look? We still have QA. We ran our extensive integration tests. Then alpha, which covers all scenario tests. Then the build is promoted to beta. And then once enough traffic is collected, we ran through all our monitors, metrics checks. If the metrics checks are all good, we promoted that to gamma. Gamma, as I said, once we had enough traffic and with respect to load and stress testing, then it goes to production. So this was how our pipeline looked after phase 2. So now coming to the pipelines, plugins. In this phase, what plugins helped us? Two plugins I would like to call out are parameterized plugin and rebuild. Because we had more steps in the process, parameterized plugin really helped us to pass parameters from one job to the another all through the pipeline. So consistently, for example, we were using version numbers. You will see in the other lightning talk, like how the version number gets passed on throughout the pipeline for better traceability. And then the rebuild plugin. One of the things was, because the pipeline has a lot of steps, for example, say one of the monitoring checks was broken due to some external reason, we didn't want to start the pipeline all the way from the beginning. So rebuild pipeline helped us to trigger the pipeline from where it was broken. Next one is downstream build view. This is more of on the visualization side of things. So every job instance, we were able to see, like, say, build 1 of this job ran build 2 of the next job. These things, actually. The last one is test-ng. So as I mentioned, we wrote a lot of metrics and then metrics checks. But to make it consumable format to Jenkins and make it very easy, the way we did it was, we wrote all the metrics in terms of tests. For example, if an API call, the latency goes up more than 100 milliseconds, it says test has failed. And it passes as a test-ng result to Jenkins. So this helped us, so Jenkins can easily show there are 200 metrics, 180 passed, 20 failed, and you can drill down why it went bad. So we were very excited. We thought, that's good. Everything is looking good. So we saw the results. Change-related issues went down drastically because stuff was being caught automatically and in phases. So before it hits even our internal servers, we were able to catch it more or less in alpha stage. And whenever we found stuff in beta, gamma, they used to become integration tests or alpha tests in the future. Second thing, developer productivity. What do you guys feel? Did it go up? To our surprise, it went down overall. So we were shocked. What went wrong? What is happening? This is supposed to improve the process, but then still developer productivity is down over an overall way. So then we were we spoke to several people. This was the common complaint. They said, I don't know, but I'm still waiting for the pipeline. We were met with this. Then we took a step back, looked at, spoke to developers and see the most frequent complaints or comments. First one was, it's not my change, I'm not fixing it. As we introduce more and more tests, alpha tests and stuff, so for example, I make a change, it broke alpha test, then James makes another change, but then I'm away or something, and I didn't monitor the pipeline. So James is blocked because obviously the change is, the failure is not related to his change, so he's saying like, it's not my change, I'm not fixing it. Second one, pipeline was blocked, so people were saying like, oh, pipeline is blocked, I'm going to go play foosball. And from the release side of coordinating things, what happened was, like when things got out of hand, for example, tests were being broken, changes are kept coming in, so we used to enforce merge freezes. We used to say, hey guys, let's stop what we are doing, let's not merge anything, let's figure out what are the problems, then go back, fix them, and then restart the pipeline. But this wasted a lot of time. And again, coming back to us, like when nobody owns it, it's of course the CD team. Even with the code change, people used to say like, hey CD team, can you take a look at it? So not just developer productivity, our team's productivity was also down. So we wanted to improve it. So with that, I hand off to Gopi, who will talk about phase 3 and how we tackle these challenges.
Thanks, Aravind. Okay, so we are entering into an important phase of our whole CD pipeline. So at this stage, lot of negative feedback from our number one customers. You guess it right. It's our developers. And then we started thinking, what's happening? So every developer's mind speak the same. It's like, okay, we need the pipeline. We need the instant feedback. So let's see. Okay, so what is the dev's feedback? So what the dev feedback is like, they need an ideal solution. So they make a change, they push it to a SCM system, it can be anything, and they make a build in the continuous pipeline, Jenkins, and they want to get an instant feedback. So dev mind says this at, okay, what it means. So once they get the instant feedback, so we thought like, okay, we went to the board and then we decided like, what are the main challenges we are facing. So the first number one challenge what we are facing is our CD workflow, is it enough? Definitely not enough. So we were thinking like, at the same time, we can't complain like our CD pipeline is broken because we were doing good, we were having a commit stage, assembly and deployment stage. It was all going good, but at the same time, the developer feedback was very bad. So what was the next major challenge? The next major challenge was the infrastructure, is it right? Okay, so what it means, so every developer needs instant feedback, right? So when you make a change, they want to get an instant feedback. So for that, is the infrastructure, is it scalable? So you can imagine like there are like hundreds of developers around, and then they want to know what's going on for every code change they make. So which means that we need to have better infrastructure, more slaves, more everything, right? And we can't ask every developer to travel on the same bridge. So we need to build different bridges, which means like different pipelines, a mini pipeline kind of model for every developer. Okay, so let's see how we solve this problem. I understand it's 3:30, so everybody should be feeling sleepy. So let's quickly recap what we did. Like the phase 1 of the CD workflow, we had 3 stages like commit, assembly, and deployment stage. And then we quickly realized like the deployment stage is not enough, so we want to revamp that. So that's when we entered into a phase 2, where we had like a different stage-based model deployment. But again, we, as Aravind was saying, like the developer feedback was like, no, it's still not good. The developer productivity got lost. So we thought, okay, let's fix something even before the code enters into the pipeline. So which is the commit stage. So at this point, we looked around, and as per the industry standards, they say it's a diff testing. Somebody say like pre-commit or a pre-review pipeline, whatever you call. This is something like a very interesting thing. Every CD groups across the industry should work into it. So that's definitely increases the developer productivity a lot. Let's see what are those. Okay, what is more about the diff testing? So I am as a developer, I send in a code to a code review system. And the code review system can be anything. It can be a Gerrit, or it can be a GitHub, or whatever it is. So once I send the code into the code review system, immediately it talks to Jenkins and triggers 2 different jobs in parallel. Okay. So the code, right, what it uses for building, it should be definitely latest code. So what if the developer made a change, it should be a top of the latest code. So how we handle that? We do auto rebase of the code. So we do auto rebase of the code and then it pass it to the 2 jobs. So one is the first job is like similar to our commit job, what we had the phase 1, which does like style check, unit test, static code analysis, all those stuff. And the second one is the integration test job. So once the first job is done, it sends the results back to the code review system, whether pass or fail. If it's pass, it's okay. Immediately it gives the details to the code review system. If not, again. So once this is done, parallelly the integration test job keeps running. And definitely, as you see, the integration test job takes more time compared to a unit test job. So it will be instant, but this guy takes some more time. And at this point of time, we need to have servers, right? So every code change needs to get to deploy to some servers, and then on top of that, we want to run the test. So how we handle that situation? So what we did is like we leveraged here like cloud services, and again it's generic. It can be anything like OpenStack or AWS or whatever it is. So these cloud services provision the servers to you, dynamically, okay? So it gets the servers. On top of that, what are the packages you built, you will copy it to the servers. So I just want to make a mention here, like we are not like putting it in some state management system or something like that, because these are short-lived packages. So we SCP or copy them to the cloud services, OpenStack or like AWS boxes, and there we run the integration test. So once the integration test are ran, we send the results back to the code review system. The beauty here is like we keep sending them as frequent as possible. And then once the results comes back to the code review system, the code reviewer, he will take a look at the results along with the code and then see, okay, it's good or bad. And then if he feels good, then he sends it to the SCM master. So he merges into the main master. So now you can understand, right, like how the flow goes. So once it moves to the main master, from there on, it's like a regular pipeline. Like the assembly stage and the deployment stage. So as you see here, like it's happening for a single developer, the complete flow. And then we scale it up like it can run for any developer, any number of developers, 50 or 100, it doesn't matter, right? And one thing I like to point out here is like we leveraged concurrency plugin. So that plugin was very helpful for us. Generally if you see Jenkins job, it goes in sequence. But the concurrency plugin, it can run like parallelly. Only thing it needs the slaves for that. So that's why I was saying like infrastructure is one of the issue we was seeing like, and we are trying to solve that. So scaling the infrastructure, once you scale the infrastructure to take care of that, then you're good. You can run n number of jobs. So the concurrency plugin helped there. So with this diff testing phase introduced, right? Let's see how our CD phase 3 workflow. The complete workflow is like, as you see, multiple developers, they are all keep checking in the code at the same time. At the same time, like code review system is getting triggered. It's giving train the jobs in the Jenkins. And then parallelly, the provisioning is also happening. And then as you see, the integration test job, like everything is going in parallel. The compilation is going in parallel. Package state generation is going in parallel. And then provisioning the boxes is going in parallel. So once you get all those things, you are running the test, you are sending the results back. What we have done is like here, every stage we keep sending back the results to the developer. So like unit test pass, good. If your static test pass, good. Your integration test pass, good. So he's getting the instant feedback, so what they requested for, right? So once all these things are like done, as you see the complete pipeline, then it goes to assembly stage and then goes to the deployment stage. So the developer is very happy here. And also the other part is like we posted restrictions over here. With the code review system, you can control who, when, where, and what code you're going to merge. So those kind of restrictions you can post there. And also it helps the code reviewer mainly, right? So generally in companies like code reviewer will be like top guys, they will be busy handling multiple things. They don't want to spend time on the code review. So they say, okay, send the results back, then we'll see if it's all good, then we'll merge it. So that was helping a lot, the code reviewers also. They were also happy, not only the developers, right? So the results. So coming into the results, change-related issues down in the main pipeline, definitely, right? Because we are catching it early in the pre-commit or like diff testing stage. So, and it's all again per developer change. So it was very good results. And developer productivity, definitely way up. So like the feedback from the developer is like, oh, nice, I'm getting instant feedback now. So they're all happy. No more foosball, no more like, no merge freezes, definitely, because like that was one of the major complaint with the one single pipeline flow. There were a lot of merge freezes were there, but that's no more merge freezes. And definitely like only the developer who makes writes bad code, definitely he'll be like got caught early, right? And also like, so yeah, so developer productivity increased a lot. And then if the only case where the main pipeline will be broken if the code reviewer by mistake merges a bad code. So that's when like the issue starts, or else like it's all good, all right? So with that, let's see what holds the future for us. Like with the phase 3, you got a complete picture. The big thing is infrastructure as code. So now we are trying to integrate operations teams also into this workflow. So like not only the developers, we are looking into the operations side of things also, and we are trying to say like, okay, we can build this pipeline for the operations also. And that's when like anything going into the product, not only the developer's code can be automated using the CD pipeline. So that's what holds next. And there's a another interesting problem solved that side. So no changes to the product can escape and go to the production, right? Okay, for more insight into the CD learnings, we have a lightning talk coming up. So we're going to discuss about what are the main 3 principles we learned in building this pipeline, which evolved from nothing to like a very high-end CD pipeline. Please try to attend. It's from 4:30 to 4:45. Thanks to our sponsors. Thanks.